Well, good morning, everybody. Thanks for coming back. I hope you're having a good conference. Hope you've learned a lot. This morning, we hope to really stretch your imagination as to what's possible in the area of housing. You know, we've talked about how we're going to change our energy systems. We've talked about how we're going to change indoor air quality and atmospheric management in the home, the structural components of the structures that we build. But today, we're going to talk about alternative construction. It's something that you probably have seen in the building press, whether it be modular, volumetric build, whether it be cementous product, whether it be a printed product. And we have two guests from Diamond Age today who are going to be able to take us through really the future of what I call robotic home building, kind of larger than just a cementous product, but really robotic home building. But we're going to kick it off kind of talking about whether or not these alternative construction processes are fad or future. You know, there's a lot of press out there. Certainly, there's cases to be made that there's been the area has been kind of overhyped. You know, we've had a lot of people spend a lot of money. Prop tech venture capital has invested over $21 billion in alternative prop tech in the last few years. And you know, there's been some catastrophic failures. We had Katerra, where over $2 billion was invested. And Katerra ended up going bankrupt. We had Integra, again, another extremely well-funded enterprise, even had insiders like LP as primary partners. It also went bankrupt. Recently, in this past 6 months, we had Vive go bankrupt. So, you know, I think the question out there is, well, gosh, we've had all of this venture capital pouring into alternatives in the building space. Well, why are these companies going bankrupt, and is it still a thing? But I think you have to go back to the original motivation to change. You know, why are we even looking at alternatives? And it boils down to the key things of profitability for the builder, headaches on the job site, shortages of both materials as well as labor and skilled trades, the timeliness of competition, labor savings, and fewer trades to manage and simpler construction process. So you kind of boil it down. It's all about waste elimination, availability, and customer experience. If alternative processes can use less material and waste less material on the site, if the labor is available and easily pulled together for construction activities, and the customers accept it, then there's a there there. So let's look at time management of construction. This is kind of the first thing that I did when I got into the construction business. Is I was working with a production builder, and we did a time study of the traditional construction process. We have about 160 hours a week available for construction activity, right? I mean, there's 7 days a week, 24 hours a day. Except we don't really work that. We time on site generally only have about 40 to 72 hours on site. So immediately, we're only using about 24 to 43% of the time that's available to us. Then on top of that, if you look at the actual schedule, we have multiple times where there's no trades assigned, or there's no shows, or we have delays in the schedule. So the reality of the time that we use on site is we only use about 15% to 30% of the time that's available to build a home. So right off the bat, anybody in construction here knows we don't use our time very effectively. So if there are methods that can change this, that can allow us to work on rainy days, that can allow us to work, you make sure that trades show up every single day, we can have a smoother, even set type production schedule, then we can simply use time more effectively. So we start our construction process by wasting 65 to 80% of the time that we have available to us. Now, the next thing is, let's talk about, the direct materials that we use. A traditional build process employs about 2 to 3 dumpsters per home. You know, these are roll-off containers, right, that we take all of our trash and all of our leftover materials and we throw into dumpsters. And we pay for this stuff to be removed. But a lot of this material is actually good material that was damaged by on-site delivery or inaccurate takeoffs or poor on-site material handling and planning and construction errors and a lack of any kind of reuse program site to site in the job process. Now, I have firsthand experience here. I actually ran an environmental waste recycling company at one point in time. We we had this equipment that would grind up all of the organic material for a builder, and we would leave it on site so you wouldn't have to take it off site. And it's this huge piece of hydraulic machinery with carbide teeth, that would grind up all the materials, separate out the metals, and, it'd leave a big pile, and you'd push it around the yard afterwards. It was 6 feet long, and it was 3 feet wide. It was about 4 feet deep. And the biggest problem we had on site was sawing up 4 by 8 sheets of virgin material and sawing up 12-foot long virgin material. When we bought the machine, we didn't think that there would be so much material left on site in its virgin state. And so we ended up immediately having to buy generators and buy all of the saws and everything so that we would saw up this material so that we could get it small enough to fit inside of the grinder. And we did that job site after job site for custom builders, for production builders. It didn't matter who it was. The amount of material was just staggering that was being thrown away. So you look at that, we have about 2,000 to 3,000 cubic feet of material per home. There's a perfect example of several different containers on different job sites. All of this material, by the way, could be salvaged and finger jointed and put back into virgin construction material again if we had any kind of process. Versus a manufactured home. And a manufactured home has about 2 32-gallon containers of waste in the construction of an entire manufactured home. So think about that. We have 2,000 to 3,000 cubic feet of waste, or 64 gallons of waste. So when you look at the amount of time that we waste in the construction process, in a traditional construction process, you look at the amount of material that we waste in a construction process, you realize that, one, we're only using about 15% of the actual time available to us to build, and we are wasting 10 to 20% of our direct material. Now, the third shoe to drop on the housing is workforce availability. We have a dual problem. We have the problem, first of all, that young people aren't interested, as they have been in past decades and past generations, in getting into the trades. So we have a shortage of young people entering the workforce, and we have an excess in aging workforce on our end of the spectrum. So we are aging out, and we are not replacing it with new people that want to work in the trade spaces. So if we're only using 15% of the time available to us, and we're throwing out 10 to 20% of the material that we buy every time, and our employee base is retiring, and we're not replenishing our employee base, those are the fundamental underpinnings of why we have to start thinking about, are there different ways to build? Are there simply other ways that we can get at this? And this is just the number of construction employment jobs you can see year after year just keeps increasing because of that problem of not enough people entering the market. So from my perspective, the future of home building, excuse me, is in a variety of different techniques, whether it be components and subassemblies or modules or volumetric build, additive manufacturing or robotic specialization or human augmentation. We're going to see a combination of all of these things begin to permeate everyday building in every place that we go. And I'm going to show you some examples of some successful companies. We talked about Shawwood and Sekisui House, previously. Well, the key to Shawwood and Sekisui House, right, is this construction process that they have. They basically have this kitted, framing process. This all comes to the site. Each 2x4 is numbered and serialized. It's precision cut on CNC equipment, right? It has a proprietary joinery system that goes together. It's much faster to build, much stronger process. You don't have people picking out 2x4s and cutting them off and throwing them in dumpsters. Everything that's delivered to the site is actually put into the home. There's no waste on the site whatsoever. So it's just a different kind of componentized delivery, creating a much superior, from a strength perspective and consistency perspective. Then you can kind of go up from components and you can start to look at modules. Plant is probably one of the best funded and largest and certainly most talked about modular manufacturers in the company. And they have a system of modules that they can make in the factory, so they can use 24 hours a day, 7 days a week. They can run, if they want, 3 shifts a day, 7 days a week, so they're not wasting any time. In a factory operation like this, any cutoffs can immediately be put back into finger joiners and made back into dimensional lumber, so the amount of waste is dropped dramatically. And then they can ship these modules out to the various locations. And they do this with multifamily type applications. They do it with single family applications. They even do it with small ADUs. So you're starting to see the application of component systems coming. Now we also have a completely different approach on OnX. OnX is also a modular manufacturer, but in their case they use a cementous product. They actually create cement modules in a factory, bring them to the site, and slide them all together into the kind of homes that you see up here. They have a variety of different robotic technologies, both in the pouring of the concrete, the rebar forming. So again, they're using a factory, they're using robots, they're reducing the amount of labor that they have. The people that are attracted to these jobs are very different because they're not having to work out on a roof, right? On a hot 120-degree day, right? They're working in a factory, and many of these cases, the factories are actually air conditioned, so it's not a really tough, demanding job from that perspective. And then you get to the volumetric side of our business. The volumetric build is where we're going to build basically the complete home, and we're going to ship the home to the lot. Volumetric side of the business, obviously, is kind of the epitome of being able to use the advantage of a manufacturing system. It's fully factory finished. It's the least on-site labor. You have automation and robotics within the factory. You have factory qualified, quality checked. 24/7 operations, materials. You have everything that you want to do. This market has been dominated by people like Clayton Homes and Champion, and has kind of a stigma in the U.S. as being a kind of a lower product, lower quality product. But the efficiencies are incredible. If you look at the amount of labor that it takes to finish, at $20 an hour, they're building homes for about $2 to $4 per square foot from a labor perspective. I mean, it's just stunning, the labor efficiency that they're able to achieve. And of course, you can build anything you want in a factory. You can build a custom home. You can put all kinds of quality finishes in. The fact that our current, mobile home business that we have in the United States hasn't done that. If you go to Europe and you go to Japan, mobile homes are considered a premium product. People pay more for factory finished homes than they do stick-built homes. And we're going to get into that in this afternoon session about how do we market better homes. And both in Europe and in Japan and Asia, they've been able to turn the tables completely around, and the consumer public doesn't even want a stick-built home and a used home. They want a factory-built new home. And there's reasons for that, and we'll cover that this afternoon. This is probably one of my favorite examples. It's a company called Fading West. It's in Buena Vista, Colorado. Charlie Chupp was a founder and runs this company. There's no better place for a factory than sitting there at the base of the Rocky Mountains. They go to work there every single day, right? It's a great place to go. But they do volumetric build, and they have a very specific model. They're sitting here in the high country of Colorado. It is basically a labor desert. This is not some place that a lot of carpenters and finish carpenters and roofers and plumbers can afford to live any longer. So they have a real problem up in this area building any kind of affordable housing. So they are looking at, you can see in the very lower piece of that square, that's Buena Vista, that's where their factory is. They kind of serve that area. They serve Aspen and they serve Breckenridge and they serve that whole ski resort, high alpine area of Colorado. And what they build are complete volumetric builds. You can see that in the upper portion of the quadrant there. And they deliver them in single pieces, but the finished product is what you see down in the lower right. This is not your typical mobile home, right? This is the roof pitches are nice, right? The architectural detail is beautiful. These are Energy Star, rated homes. They have net zero compliant homes as well. These are well-built homes that are being delivered throughout Colorado. It simply allows them to build in what can be as short as a 6-month building season. Because of the extreme weather up there, they have a very small window of how many months they can actually build, but they can set and finish a home easily within that 6 months, because you can imagine the on-site preparation is mostly just the foundation, and they tie the two homes together and you're done. The two pieces of the homes together and you're done. And then that brings us to additive manufacturing. And additive manufacturing is a thing. Additive manufacturing is, instead of taking raw materials and cutting them down or milling them down or machining them down to the shape you want, additive manufacturing is the concept of taking basically molecule by molecule and building them up into the shape that you want. And this is now happening in the health service sciences business. This is happening in automotive parts, military parts, aerospace. We're seeing this in all kinds of different industry. You can get very innovative and unique designs. It is inherently a zero waste production process where you have a single process that finishes the product completely. You have low volume economics for this and unique fabrication materials. And we have begun to see this now in housing. There are two premier kind of leaders in this space in the United States, which is Diamond Age, which are the two folks that we have sitting right here. And I hate to tell you, but we're going to say the word Icon. Icon is another company that has been pioneering this in the United States as well. And I think the fact that there are two actually bodes really well, because I think what it tells you is that there's kind of a there there. If there was just one doing it, you might question just how crazy you are, Jack.
I'll tell you a surprising story today, Tim.
but there's more than one. So you're starting to see multiple players in this space in the United States. The products that they build are 3D printed products. These are homes in Austin, Texas, where a community was built. Here they built a single-story home and then finished the upper story with a more traditional stick frame built. Right now in Austin, they are completing this community. This is a 100 unit community called Wolf Ranch in Austin, Texas. It's 100% 3D printed. So it's no longer kind of a small, esoteric, we do it here, we do it there. This is now just a mainstream. If you go to Austin, Texas, and you go shopping for new homes, you're actually going to see 3D printed homes as one of the methods of construction as you start to look around communities within Austin. Diamond Age builds a similar beautiful product, 3D printed. We're going to hear a lot more about that with their technology. And for that, I'm going to turn the clicker here over to Jack Oslan, who is the founder and CEO at one time of Diamond Age as well. So Jack, take it away.
Yeah, thank you, Tim. Appreciate it. Also to my left is Ryan Simpson. Ryan leads our engineering team, and I asked him to sit in with me this morning, mostly because he's a lot smarter than me, and he'll take you through sort of the automation side of Diamond Age. I'm here to tell you an origin story of how a technology company gets into the legacy home building space. And it's interesting, Tim, I appreciate the lead in there talking about the failures of the industry and having been categorized as a 3D printer. You're going to hear a little bit of a surprising story from me this morning. And it's a story that is not unique in the world of technology startups. So, Diamond Age, automating construction at scale. What does that mean? This is not unusual, this information, and actually this is the wrong presentation. So I'm going to sort of differ from this a little bit. I'm somewhere in the transition of writing this thing, we've got a little bit different information here, so I'm going to ad-lib a little bit. I hope you guys don't mind. I recently went through the census data. There's a guy named Kevin Erdman who publishes a blog around the economics of home building, and he'd made a comment recently that we are 10 million homes short in this country, and I had always been stuck on the number of 5 to 7 million. I went back and double-checked all the new household formation starts and closes over the last 20 years, and he's right. By the data, we're short 10 million homes in this country, which is tragic because it means we've got a lot of young people who are being left behind on the real estate ladder. And that is the problem that Diamond Age is trying to solve. We know homes aren't being built fast enough. We know fundamentally that skilled labor shortage is the problem. So that's the problem that we're trying to solve here, and how to figure out how to do that at scale, because that's the only thing that's meaningful. Um, we're a construction automation company. I want to double down on that statement because Tim introduced us as a 3D printer. We started out exploring 3D printing. We thought that was really a novel idea and had a lot of legs. So we spent several years exploring that, and we'll show you some of the 3D printed homes that we built. But really, our core competency is robotics and industrial automation. And that is what we focus on because the solution is potentially changing. It's certainly changing for Diamond Age, and it's the ability to have people like Ryan and his amazing engineering organization with this incredible diversity of engineering disciplines that makes the opportunity to follow a potential solution with automation wherever it leads you. So that's important. So our origin story is pretty simple. 2017, my son called me, told me he couldn't afford to buy a house, and he was going to move his family away from me. And that pissed me off. I had just gotten a grandson, and now he was going to move away from me. And I couldn't really understand why he was in that predicament. Fundamentally, if he was, let's say he was a store manager and his wife was a school teacher, I might understand that. But they are both high wage earners in Silicon Valley. Between them, they bring home over $500,000 a year. And I just couldn't understand what was stopping them from buying their first home. Now, granted, the Bay Area is an expensive place, but $500,000 a year, you got to be able to get the job done with that. And the problem is I hadn't been paying any attention. I hadn't bought a home for 30 years. So I didn't really realize the scale of the problem. So when I looked under the hood and saw it for what we all know today is a supply and demand problem that's been built up since 2008, it becomes obvious. And this is actually my third technology startup. Every one of those companies was born from me being pissed off about a problem. You have to have some emotional motivation to do a technology startup because they're hard, and this one became personal. So in 2017, I reached out to a friend of mine who was an engineering executive at Tesla and said, I've been looking at these 3D printing companies that are starting to come into the market, and I think that has some potential. But I have real doubts about the industry and the consumer base's actual desire to adopt an unfinished, uneven concrete wall. So what do you think would happen if we could actually solve that problem? And we started out with this requirement that we had to deliver familiarity, because I didn't believe that home builders would accept a product, at least not broadly, that didn't look like the product that you were already producing. I didn't believe home buyers would buy a home that didn't look reasonably similar to the home they grew up in. And I knew for damn sure that regulatory was going to have a hissy about something that wasn't in the building code. So we set the baseline for the company of delivering familiarity to all the major stakeholders. Now, the key here is that it had to solve for labor, which is automation. My co-founder brought early employees, some of his consigliere at Tesla with him, and we set up shop literally down the street from Tesla. I could probably give Ryan here a 7-iron and he could hit their front door from our parking lot back in those days. We did that on purpose because we were asking guys to work all day and then come and work for 3 to 4 hours every night trying to figure out this 3D printing thing. And we did that for 2 years. I literally paid guys with beef jerky and Red Bull for 2 years, trying to convince them that this was a worthwhile enterprise. And we got to a point where we thought that we had a 3D product that we'll show you here in a second that would do the job, but it was going to require additional automation. A lot of robotics to do some of the further finishing in a house, because again, we didn't buy into the aesthetic of unfinished walls. So those were our humble beginnings. Okay, we'll show you a little video of what we've accomplished to date. So this is an aerial view of the first community that we built for Century. 30 homes, 3D printed, several robotic finishing techniques here. You're going to see a prototype of, this is the actual probably 5th generation of the print tool. This is our endless brick system. This is a prototype of a nailing robotic tool for sheathing and a truss rolling tool on the gantry. Some of these tools were amazing. The problem that we discovered here is that we couldn't get paid for all the value that we're creating. So this is a 1,500 square foot Century complete home that's 3D printed with a hybrid wall system, looks just like their stick frame counterparts in other communities. And that was important to us. One of the other things that we've done is we have a letter of intent with the country of Ukraine to use our technology to produce bomb shelters for them. This was a little informal ballistics testing that we did to prove that we had some high level of ballistics resistance that would work for them. I was making the comment to the gentleman from Taylor Morrison that now that the Senate has passed this new bill, we expect to see some activity from the Ukrainian government to get this gantry technology of ours down there to start producing bomb shelters to help them in their continued conflict. So what we've done to date is we've built a suite of robotic tools and an operating software system, as well as some support software systems. And that's important to know because the software that we've created is really the secret sauce. Everybody oohs and ahs about the mechanics and the robotic tools, the hardware, but as the saying goes, software is eating the world, and it's no different in the home building space. We patented a hybrid wall system, combination of dry stack masonry, post-tension, composite foam. An amazing wall will withstand a 315 mile an hour hurricane. Certified for seismic B, which is 92% of the United States. Really remarkable. So we were excited and we thought we really had something going there. Again, we built these 30 homes for Century, and but what we learned in the process is that we couldn't get paid for all the value we were creating. Because at the end of the day, and you all know this, that if you don't get to parity with on-site stick frame construction, it's just not going to fly because everybody's got to make money. So demand keeps going up. The amount of labor that was involved with the system, Ryan made a comment once, which I, in the moment, was taken back with, but it is so apropos, is that we were really only solving problems that we were creating for ourselves. And that's when you know that you have to take a hard look at your business and say, how are we actually going to solve the labor problem so that it's accretive for customers? So we shifted our focus from solving the entire construction stack, right? We started out as a technology company, and every technology company wants to disrupt the industry that they're going into. when what we realized is we should just be focused on being easily adoptable and accessible for the industry. And so we pivoted to create a product that was easily adoptable, not just because it worked within the supply chain and the familiarity of the product, but because it had cost parity. And we're going to talk about that here in a second. Where are we? So what we've pivoted into is a integrated wall panel product. How did we get there? How did we go from 3D printing to a wall panel product? Well, in our cost down exploration, trying to make 3D printing work, we realized that we didn't need concrete walls on the interior of the home. It was really only the exterior that delivered all the value. So we were looking at light gauge steel framing as a replacement for interior walls. And as Ryan and his team really dug in, the question got asked, why don't we just make the entire home out of light gauge steel? Because we have this integrated panel that we can automate. Now, light gauge steel, we refer to it as a light gauge steel. It's sort of the internal moniker for it. What's great about light gauge steel product, and you guys may be familiar with this already. I mean, the commercial construction space, it's old hat for them. So it's a product that's easily automatable. It's dimensionally accurate. It's dimensionally stable, and automation loves that. Really, automation hates wood because wood warps, bows, checks, cracks, full of knots. It is not consistent. So using a cold form steel machine, we can make beams and tracks that actually work great in a robotic factory environment. So we are Teslaizing the product, and I'm going to turn this over here to Ryan in a second to explain to you exactly how we're going to do that. But then these panels can wind up on the job site. They will have all of the rough-in MEP in them. They will have the interior drywall on them. They will have exterior insulated foam panels, which double as the moisture barrier. It literally is a complete product that can be snapped together and stood up in a day. And now, I don't know if you guys know, Century Communities is our customer, but they're also a major investor in the company. So we sit in the room with Century and we pressure test what we're doing with them. And they're a tough nut to crack. Everybody is very sensitive to the cost of construction, so they don't cut us any slack. And that's the way we want it. And that's how we got to this pivot in our technology path. Is we weren't delivering cost parity. Now we're going to deliver cost parity, and we're going to do it in a way that Diamond Age can actually be profitable. Tim talked about all the failures that have come before us. It's unfortunate. We need all the homes that we can build, so we need more companies to be profitable so we can be here for the long haul for you. So we really need both sides of the equation to be profitable in this endeavor. So Ryan, here I'm going to let you talk about panelized wall construction and how we're automating that and carving cost out of it for these guys.
Yeah, definitely. So this is kind of our workflow that we have up here. Tim made a comment and Jack made a comment on the previous panel. Why steel? It's highly automatable. It's very dimensionally accurate. The other thing is with wood, it comes in very specific sizes and you have to cut it. With steel, I can make it at any length and I have no scrap. So it reduces scrap very, very low. You're only scrapping it if something gets damaged because you don't have to cut any parts out of it. So first step is roll forming the steel studs and tracks. I'm going to kind of give you a high level of all this and then touch on a little detail. After that, we put it together with framing. We install all of your MEP. Romex, Century currently wants us to do Romex. I've talked to some people here already that don't want the Romex installed, so we don't have to, but we can do electrical boxes, PEX, vents, pretty much anything in that section, all the way down to sheathing installation. So working with a couple of our installation suppliers and everything, we realized, how can we automate this? One thing is light gauge steel needs a foam barrier on the exterior for the thermal conductivity and everything. Well, if you just make that slightly thicker, you don't need insulation on the inside of the wall anymore. So now I don't have to deal with cavity insulation. So we've got that approved to use a thicker insulation on the exterior, no cavity insulation on the interior. Helps with automation, helps with scrap rates and all of that, and just reduces some complexity. We CNC cut all of our foam, all of our drywall, so it's very accurate. There's no scrap other than the material that is cut out of it. And then we would use door material for kind of fixing patches or anything like that. So trying to reuse all of that material. The other benefit of steel is it's 90% recycled material. So all of our coils that we get in are 90% recycled steel already. So you're helping that cause. This is kind of our manufacturing line. So Jack said it, Teslaized it. So I used to work at Tesla. I used to head up a department at Lucid Motors. Automation is everything that I do in my entire career. So we built a line. We got tasked by Jack and our new CEO to make a line very quickly, 45 days. It's one of the fastest manufacturing lines I've ever had to put together in my career, but it's going. We're launching on May 6th of this year, and we'll have a ramp up through June and then be fully in production in June. So this line here starts on the left where the steel studs and the tracks go in, and that's kind of where the human interacts with it and kind of leaves it to the robots after that. So it will go through the line, the steel will be picked up, prioritized into a panel, clicked all together because they're dimpled and locking mechanisms in place. Shifts over to the right, robot will screw all of the material down, rotate it, finish the screwing, kick it out. And then there's just a kind of an inspection station. Really, that's there for the very beginning of the run so that we make sure that nothing went wrong as we were putting it together. The very big cell in the top left corner there is where all the MEP is installed. So you feed it all your electrical boxes, all your mechanical boxes, all of your PEX and vent line sub-assemblies together, and the robots pick them up and install them all. Moving forward to the bottom right is where you're doing your panelization. So you have a, let's see if this works. You have a CNC machine right there, and then you can load drywall and foam here. And we've got a bunch of big robots moving around, doing all of this work. No people. We're probably running very few people on this line. They're only there to fill MEP. They're there to fill screws. They're not touching the product. The robots are doing all the product. So you're reducing your labor from there. You're increasing your quality because the robots are doing it. And you're reducing all of your scrap. The other thing Jack had mentioned, we're kind of a software company at our basis. We wrote a bunch of software for 3D printing to interact with CAD models. We actually took that and took it a step further into this. When you do a lot of robot programming, like at Tesla or anything like that, it's the same thing over and over again. And that's what robots are really good at. Panelizing walls for, let's say, all of you guys is different. All of your walls are different. All of your houses look different. We've actually wrote extensions. We currently use Revit right now, but we wrote extensions in Revit so that once our architecture and our structural engineer get a hold of it and get buy-off from the customer, they can click one button and it will send it to the line and the line will just start producing it. So there's no people interacting with any of that. It's all software that we have written. So it talks to our roll forming machine, lets it know what studs we need, what tracks it needs. Once those are all out, they will feed it into the robot and let them know how to assemble everything.
So from, just want to clarify, so from a builder perspective, if they do Revit and include MEP in it, then you can just take their three-dimensional Revit drawings with MEP and instantly you've got assembly instructions.
Yep.
And it can go right to the line.
Yeah. Yeah, and then the line, let's just say there's nothing happening on the line. And you gave us that model's bought off. Once we click that button, that house will be produced in about 10 hours. So it just comes off the line, all panels ready to go in order.
And then the panels shipped to the site. How are the panels connected? Are you going to get to that on site of how you connect? Okay.
Yeah. So here's a couple sample walls. This is a wall that we're doing for one of our customers. It's their bathroom wall, so you can see the pecs and everything. This entire thing is built via automation with the robots. The sub-assemblies are just snapped together by people. Very easy instructions for them, not doing a lot of complex things. So you get down to that $20 an hour person and using very little labor to do that. Then the robot will install them, screw all of this down, and lock it all together. And then you can see the finishing of the drywall, which is also handled by the robot. This is a door example. This one has electrical in it. You can see at the very top, we've coiled a Romex section up there and gave a cutout for it. Pretty much what that is when you go to the site and you have to land it on the foundation, you don't want to home run everything back. That would be very costly. So what you do is the Romex cable is all cut to length, and then it's coiled up inside the wall panel. Once you land the walls, they have a drawing or a schematic that shows them which way to run the cable, and it just lands to the next box, daisy chaining them together, and then one of them is marked for a home run, and then you go back to the panel. So very easy, very Lego or IKEA-based product. For this to kind of like land this on the ground, I can't really see. There are holes down here in this section, in this panel, and those holes line up with anchors. You either hammer and wedge anchors, or you have the anchor standing up where we just drop the panel on and lock it in. And then how we keep them together is we have a interlocking mechanism between all of the panels, and then we just run a strap across the top of them to lock them in place.
And the manufacturing cell looked pretty small.
Yes.
So, with modular and volumetric builds, the big bugaboo for that is always shipping. Right? That's always, you have a factory here, you're shipping 300 miles, you lose all your economic benefit because you're shipping it so far. So is your concept to actually build these, maybe even multiple of them in a single metro market where you would be shipping in very short distances? Could you speak on that?
Yeah, this concept is all about what we'll refer to as a micro factory. So one of the big problems that we were experiencing with the 3D printing and robotics was it was a very high CapEx hurdle to get over. So the unit economics were very difficult to achieve. So a single line that's got a 1,500 home per year capacity, $4 million. I mean, the unit economics on that are unbelievable. Even to the degree the venture capitalists are super excited. And those guys, they only get excited about time travel and things like that. So,
but it also seems like you could pick up this cell pretty easily and just move it. I mean, it does, it doesn't look that complicated. Right?
It is.
You can pick it up, move it to the other side of town if that's where your development is. And
Well, look, I mean, again, it's about, we think of, we're currently in Phoenix, right? And right now,
which is a big geographic market, right? You don't want to ship all the way across Phoenix.
Yep, exactly. But right now, if we looked at the customers, and again, I should define customers for us because we started out and we wanted to serve the big production home builders because, again, the mission is to get first-time home buyers into their first home faster. That means we've got to build more homes so that they can manage the cost of those homes, keep them attainable. So we looked at the big production home builders as the fastest way to accomplish that. So we start to talk to Century and Horton and Lennar and Woodside and, Pulte. And all of a sudden you start to look at the footprint and you look at the west side of Phoenix.
They're all there.
They're all there. So we can, we're right now sort of in what would you say, Ryan? We're kind of in the northeast corner of Phoenix, right by Tempe.
Yeah.
right? Like, we're going to start here because we're here, right? But to go and move this thing right into the thick of it in the west side of Phoenix, and all of a sudden now you're just talking about going less than 100 miles in all directions, that's a win.
Yep.
And so, even when you start to talk about, maybe going down to Dallas or Houston, you look at anywhere up to 4 to 6 lines, 10,000 houses a year worth of capacity in a building that is not very big. That's the secret sauce. So,
yeah, to answer your question, this line right now is about 100 feet long, south to north, and 100 feet.
Yeah, you can put it anywhere. Yeah. Just get some basic light industrial space and you can pop it in.
Yeah, and it's currently designed for the factory that we're in, but then every one of these components is modular, so you can move it around.
I saw an interesting business plan for another modular manufacturer, and what they were doing is, as builders were building communities, these are larger master plan communities, there's usually some form of retail space, that they're going to stick in someplace. They'd have them build the retail space, and they'd stick their modular factory in the retail space to build the homes. And when they were done, they'd take it out and they'd put retail in. And I thought that was just a really interesting way to kind of reuse the space so you're never having to purpose build your factory, basically.
Well, one of the other things about this product is it cuts across, it's already in commercial, it's highly applicable to multifamily, and we're using it in single family. So when we talk about these master plan communities that have all of that, now we're talking about the ability to really optimize and run 24/7, 365. And that's how we keep costs low. That's how we keep the cost accessible to the customer base. It's how the company makes money. It's a win for everybody.
So I'm not trying to monopolize. We'll have some questions from the audience as well. But I noticed on your panels up there where you showed the Romex coil, that didn't show an interior wall to it. So are you shipping panels just one-sided, or are you actually a full wall with drywall on one side in?
Yeah, we didn't show the inside wall so that you could see the Romex.
Okay, good.
But yeah, we'll ship anywhere that you want. So from full panelized system all the way down to half of a sheath or no sheathing at all. This is just kind of some studies that we've done to make sure that our robots can pick up and in tandem spin a wall around if we needed to. So this is showing a 10-foot section, 10-foot tall wall, and a 12-foot long wall. So you can kind of see how big the robotic cells are, but how compact we've made them to be able to work on that.
Okay, so.
All right, so we should have stimulated some ideas out there and some questions. So what's keeping you from adopting this wall panel system tomorrow? What questions you got? There's got to be something.
Roof system.
Oh, there we go.
So roof system, we're doing your standard truss package. Yeah, and we just land it on the LGS. We've got two ways of doing it. Your normal strapping that you use between your studded walls and up, and then we're currently going through a plan to try to get listed. We can make a die that kind of makes a tab in the LGS that stands up, that it's exactly where you need to land your truss, and then you can just butt your truss against it, screw it together, and then that would make truss install a lot easier.
Good question. More questions?
Wall depth, insulating the list.
So right now in Phoenix, to get to like an R13 or 15, the foam is 1.5 inches, and then your LGS is a 2x4 standard.
Question as far as the wall panels issue.
Yeah, so windows, doors, we can pre-hang. Some people want it, some people don't want it. Depends, but we can pre-hang it, and when you land it, we can level it, and then wrapping and all of that for like stucco, and we're just going to leave that to like a stucco manufacturer or subcontractor or trade.
Yeah, the concept here is that what we want to deliver for you is effectively a dried-in shell, right? So in the beginning, we're going to self-perform and stand these houses up for Century, but for folks that want to just add this product to their toolkit, happy to just be a product supplier. So, you know, the idea of being a shell contractor is actually proven to be an attractive concept for the production builders, because we know that control of subcontractors is not something that any of you want to give up. They're a rare commodity anymore. So when you have those relationships, we want you to be able to keep them. That's where backtracking from being a disruptor and just supplying the entire homes to just fitting into a part of the supply chain became very appealing to the industry.
You get them off this line.
Yeah, so we work with a packaging engineer to package everything to, one, make sure the drywall's not going to get wet if it's out there, and then to make sure that the order of the walls is in the right place. Off the assembly line, they go into racking systems that are ordered already, and they're tracked throughout via software to make sure that you put them in the right order. And then off the truck, you take them one by one and stack them and start building.
So is the contractor responsible for the frame to pull off the truck, or is it somebody that you guys think?
So we actually will offer that general contracting service for you. If you want to own it, you can. If you want us to do it, we'll do that. We're just trying to be easy to work with.
And how big are those panels? So are they 8-foot, 10-foot wall section?
Yeah, so we go all the way up to 12, so you can go 2-foot wall to a 12-foot wall in our automation, and then 8-foot to 10-foot tall. And then with everything on it, worst case scenario, they're about 450 pounds. And that's the reason why we stopped at 12 feet, is you start getting to above 500 pounds. You need different cranes and everything for your different reaches. So we tried to stay in the roof truss crane.
And I'm just thinking like a 2,000 square home. Once that semi shows up, it's every panel on that one load.
Yeah.
Man, how else do they can get all that dropped on foundation?
It's about 8 hours.
So literally in one day,
Yeah.
the truck shows up in the morning, end of the day,
Houses, all the wall structures.
at least
standing.
wall structure standing.
Yeah.
Seems like you could almost do the truss structure at the same time.
Yeah, so
we're
we're doing it with them right now, Century, but it's 2 days.
Yeah.
Right? We land the walls the first day. Second day, we do the trusses and roof sheathing.
Yeah.
But is there any temporary bracing you have to do those panels? So
No.
they go multi-stories.
That's a good question.
Not today, but because we have so much single-story product in front of us, but you can bet we're going to get there because you want it. And again, LGS is already used for big, high rises. So it seems like a super obvious fit to me that 2-story, 3-story, walk-up townhomes, like all that stuff's feasible.
Sure. Go ahead. How do you draw up forecasting volatility to steel?
Yeah, so that is a question that I don't answer. My finance group answers that question. Right now, Century is basically keeping this initial line completely busy for, I'm going to say, the next 9 to 12 months. We will bring in enough materials to manage their forecast, but we'll have built the model by then to make sure that we're staying ahead of the supply chain.
The benefit with rolled steel is that, you can hedge your bets as long as you kind of have some sort of forecast, and then you can just store it. It's not going to get damaged or anything just sitting there.
Yep, you secure the lane down. Yes. You should. Thanks.
Yeah. So we actually, at the very bottom of it, we cut a V groove in the drywall on the backside before we install it. And then it kind of acts like a panel. So it like flips up because you're just down to that paper section. So you flip up, you can install it, and then you flip down. So you don't have to tape or mud that section.
They've thought of a lot of stuff, haven't they? Huh? A lot of details. What else we got? Another question. Here we go.
Exterior assembly first, then you throw in your.
Say that one more time.
Is your assembly first, and then you throw it into your interior wall?
It doesn't have to be. No, like right now, the way that we've designed it is to build it kind of room by room so that you don't need to stand up any other structures or brace the wall.
Just progressive.
Yeah, you progressively build out like kind of room by room.
How do you guys deal with that unlevel slabbing?
Those don't exist in our industry.
What's ours? So what do you get?
Well, the only answer I can give you to that today is that pretty much every home we've built today we've received what I call a potato chip surface, and we have built homes. Like we put that question to Century, and they say, just put it on there. Don't worry about it. We have homes that you could drop a pencil and it will literally roll to the center of the room. And they're like, it's a starter home. It's Century complete. Just let it go. So it has everything to do with your requirements as the builder, the developer.
I just wonder about how those panels might get stacked if you've got some exterior and sittings. How to affect that bottom plate? How do you do that pipe?
Yeah, we can build shims for all of that stuff.
Yes.
Yeah, and you just slide them in, like break them off.
It would be nice if we had flat foundations.
It would be nice.
It would be really nice. That's a long-standing wish for a lot of builders around this country. More questions?
Where are your active communities?
Right now, we're building about 45 minutes southeast of Phoenix in Pinell County. There's a community down there called Mountain View. What do we have? We've got another 15 homes to build in that community, which we anticipate is going to get done by the end of summer. And then Century they're already looking for the next community. There's another one probably about 10 minutes called Esperanza. It's about 231 home development that they've sort of been negotiating with the city of Eloy on for 2 years. And that's probably where we're going next.
So just so you know, that's called fast tracking in our business.
Yeah.
If they're only negotiating for 2 years, that's a fast track community. That's very good.
Yeah.
I have one more question. Is from a homeowner's perspective, right? Let's say they purchased a home and lightning storm. How comfortable should they feel on the home in regards to the amount of metal in the home versus a traditional home with lightning?
Lightning. Huh. That's an interesting question.
It is.
It is an interesting question. I don't know the answer to that, so I appreciate you asking.
That's just, and you got to ground it.
Yeah.
I'm going to leave that one on your list, man. You're smarter than me.
Any other questions? Well, we told you we were going to make you expand your mind a little bit this morning and think a little bit differently. So hopefully this accomplished that. Gentlemen, thank you very much for coming here. Could we give them a round of applause for taking the time to come here and share with us?